Okay, in the last video what we talked about was pretty much setting up this shader network that you see down here and getting the particles to render out with the volume effect. And in this video what we're going to do is we're going to go ahead and have a closer look at the particle volume cloud shader. So let's open up its PPG by double clicking on it. First thing I want to mention is that there's two ways for us to apply the particle volume cloud shader to our particles here in our viewport. And the first one we saw was by simply opening up the preset manager and going down the particles and grabbing ourselves a particle volume and dragging and dropping it and grabbing all these different nodes and plugging them in and whatnot. This is the hard way of working with the particle volume cloud shader, and I wanted to approach the hard way first because it's very important for you to know how the particle volume cloud shader works and how to connect it manually. Then in a later video we'll look at how to go ahead and have XSI do that all for us automatically and do it the easy one-click way, so to speak. Okay, so let's close the preset manager and let's go ahead and open up the particle volume cloud PPG again and start going over some of these different parameters. So we have ourselves quite a number of tabs here to go through: density, color, shading, marching, and all these different things. So let's go ahead and start going through some of these more important ones and how to set them up for your and how they're relevant to rendering with your particle volume cloud shader. Okay, so in the density tab here, what we have is some controls for controlling the density look of these particles. So we can change the contrast amount here, which of course, as you can see, affects the contrast of our particles here, and that actually looks very interesting, very different but interesting at the same time. And see, you can use this to make this softer or make it harsher. So it's a very simple control for contrast. Now, of course, we have a contrast center, which allows us to offset the actual contrast itself. So let's go ahead and leave that at the default, which is 0.5, and we'll knock the contrast amount down to 0. We can also control things like the global density and so on and so forth. Let's move over here to color, and this is probably the easiest one to understand. Here is color. We can go ahead and change the color of the particles. For example, we can make them green, and they will of course render out green. We can also change the intensity of the color, how much intensity and influence that color is going to have. We can lower that so it has less influence, or increase that to give it some more influence. It's pretty easy to use, pretty straightforward. Same thing with ambience. Ambience just adds an ambient color to the particles. Kind of works similar to the ambience and the default ambience in XSI for the scene. So we can take the ambience intensity off, and it makes it look a little bit more realistic, and it forces the lights to have to pretty much conduct all the shading for the cloud, as opposed to faking some ambience here in the scene and creating this fake sort of ambience, which can work out for you, or in some cases you may not want to use that depending on how you want your lighting set up in your scene. We can also activate and deactivate illumination, which of course if we deactivate it we won't be able to see the particle cloud. We can turn on a specular attribute for the particles. We can also go ahead and activate scattering here, which is going to increase your rendering time but make the particles look a little bit richer, a little bit more realistic, but of course at the expense of some added rendering time. We also have ambient occlusion built into the volume shader, which darkens it up wherever the shader is denser and has more particles kind of stacked up on top of each other. If we go over to the shading tab, we have some controls for lighting. One of the most important controls here is the restrict illumination lights over here. What we can do is activate this option, and we have ourselves a list which is by default empty. What we can do is we can place lights in this list, and essentially any lights that are in this list will go ahead and light up the particle cloud. Lights in our scene that are not part of the list will have no effect on the particle cloud. This is extremely useful because it gives you a lot of control over which lights you want to work with the particle cloud, because if we have say 50 lights in our scene, we may not want 50 lights casting shadows with our particle cloud because it's going to slow down our render time pretty drastically. So how does this work? Well, it's pretty easy. Simply turn on this option here, which we already did, and then click on this pick item button. That opens up this floating explorer here, and you can choose which light you want to select. So we'll select, say, the infinite light, and then just right click out here anywhere outside of the window, and there we go. Now the infinite light, and I'll show you which one it is this light here that's above the particle cloud. Okay, and let me go back. Let me just click back here a couple of times. I'm going to lock down this PPG with the little keyhole icon up here just so it doesn't go anywhere on me. And this infinite light that's up here is pointing straight down at the particles, and it does have shadows turned on. If I hit enter on the keyboard, I can open up its PPG. You can see it has shadows enabled, and the umbra is set down to 0, so pure black. So now when I render this out, you notice that the shadows and the lighting is coming from the top of the particle cloud, because that's the direction where the light's coming from that infinite light. In this case, these other point lights that are in our scene, this one over here and this one over here, are having no effect on the particle cloud, which optimizes the speed of the render and allows you to render faster, because only one light's being calculated for this particle cloud. While these lights will go ahead and light up anything else in my scene. So if I had a scene out here with a mountain in the background or whatever it is that's in my scene, these lights will affect the scene, but they won't affect the particle cloud except for this one up here. So it's extremely useful and a nice little optimization trick. The only downside to it is that only one light, or whatever lights are in this list, will affect the lighting of the clouds, which may or may not be what you want to do. Then over here we have a marching tab. Marching tab is going to go ahead and directly affect performance. So we have this simple mode that's turned on by default, which allows us to have simply one option for controlling the detail level of the particle cloud. By default, it's set to low settings, but we have 3 settings to choose from: low settings, default, and high. If we set it to default settings, as you can probably imagine, what it does, it increases the quality of the render of the particles, but at the expense of render time. And if we go ahead and set that to high, of course, that's going to take the longest to render, but the particle clouds are going to look better. And as you can see, the shading looks a lot more accurate and much nicer when I'm in high settings as opposed to low settings, which looks like this. It looks grainier, the lighting's not as accurate, the shadows don't look as nice. So that's a direct optimization feature right here to choose the quality level and the speed at which you render out the particle cloud. If we turn off simple mode, we now have access to sort of the parameters that are working under the hood to make things work the way that they do. So we have a max adaptive subdivision here, which we can increase and decrease based on how much quality and detail we want out of this particle cloud. We also have this fine volume detail setting, which allows you to select how many light samples you want to calculate per cell, and we'll talk about cells in a few moments here. Basically, the more light samples you have per cell, the longer the render is going to take, but it can lead to more accurate and nicer, more detailed renders of particle clouds using the shader. So it's something you want to take into account. Probably the best way to use this, however, is to go ahead and turn on simple mode and just stick with these settings right here if you're totally new. If not, go ahead and start to use these settings here in the advanced mode to go ahead and tweak and control your particles however you wish. One important thing to note: if you're ever getting any artifacting from the cell lookup table, you may want to go ahead and adjust some of these min and max settings for the evaluate input textures only if volume density is. Edit that stuff out of the video. I was rambling on too much after the whole light sample thing up here. So let's just edit that stuff out of the video. Start again in 3, 2, 1. So let's go up here and let's turn simple mode back on, and we'll leave it at low settings for the moment. The next tab we have over here is the Lookup Table. The Lookup Table is an optimization feature that these volume shaders use to go ahead and render quickly, because if not, these shaders would take forever to render. So we have a few different options here for controlling the speed of the render and the quality. So let me show you the main options to remember here. Cell interpolation affects the way that the cells from the lookup table are interpolated, and we can choose from a few different things. We can choose no interpolation, for example, and as you can see, now we can see the individual cells that make up the lookup table of the particle volume cloud over here. That's what all these little squares are. They're cells. Now, down here we have a cell size. Here's the key thing to remember here about cell size. The smaller the cell size, the better and more accurate the render is going to be of the particle cloud, but the smaller it is, the longer the render times. So small number equals better looking renders, long render times. Larger numbers, say if we increase it from 0.75 to say 1, will equal less accuracy. As you can see, there's less of these cells. And if I increase this, let's increase this to a drastic number. Let's just take it all the way up to 3. You can see we have very few cells. In this case, we're going to get a very bad, very inaccurate render. But you can see that the render is very fast. It's practically lightning fast. As soon as I lower this down to something very small, you can see now the render's taking a very long time. Look at that. That's taking a very, very long time. It's down to about 0.2. 0.2 is the cell size. You can see there's so many cells that you almost can't see them anymore. Just these tiny sort of little cells. Looks like a little refraction effect going on in our render region. This is good because it increases the quality and the accuracy of our particles. And we also make sure that all the particles are rendered out and none of them are missed by the lookup table. However, as you can see, the smaller the number, the longer the render is going to take. So a setting of 0.75 usually works really good for most cases. In some cases you may have to lower the cell size. In some cases you can get away with a larger cell size. So just work with the volume shader for a bit and you'll get used to that. It's a pretty simple parameter to use, pretty straightforward. We also have some parameters here for controlling the number of samples per cell for, say, motion blur. Obviously, the more samples we take per motion blur, the longer the render is going to take whenever we have renders with motion blur. So you can render particles with these volume shaders using motion blur in mental ray. Then we have a memory limit. This memory limit is extremely important because, as you can see, the max memory limit is used to prevent crash. If this wasn't here, or if we had no memory limit, essentially what would happen is if the cell lookup table got too big and too much memory was consumed, mental ray and XSI essentially could crash, and that obviously would be no good. So we have this memory limit feature, which is kind of like a fail-safe, a safety device that protects us from those kinds of crashes. Okay, so back here to the cell interpolation. The default is set to linear. Probably the best interpolation you'll get is full light trace, but that's going to take longer to render, although it can improve your renders and result in more accurate and nicer renders. You can also use cubic interpolation, which is a little bit better than linear. Sometimes it can render a little bit slower, but it can be worth it in terms of the trade-off between quality and speed. Other times you really can't tell the difference between linear and cubic. If that's the case, go ahead and stick with linear just to render a little bit faster and hold on to some of that quality. If we go over here to preview, we have this preview mode that we can activate. The preview mode works with the render region, and essentially what it does, it creates these very nasty renders with a lot of artifacting and a lot of graininess, as you can see. But as you can probably also tell, it renders extremely fast. It also allows you to preview the cells here. So we can look at the lookup table, for example, and we can change how much we want to reduce our cell size to. We can also go ahead and change different things, like we can render out the lookup table, as you can see. We can also change some different settings, like fast cell shadows. We can turn that on or off. Looks better, of course, if we have it turned on. And then we have some different things that we can enable and disable, like the illumination of the particle cloud, which of course is going to turn it off if we turn that off. We can also turn off scatter just to see how the particle cloud looks without scatter. We can also turn off ambient occlusion just to see how it looks without it, and so on and so forth. We also have this slices feature down here where we can slice our particle cloud in the X, Y, or Z axis. And let me go ahead and slice this in the Z axis so we can see this a little bit better. And essentially what this does, it slices our particles almost like taking a very large knife and just cutting our particles in segments. And we can control how many segments we slice it in down here with these parameters. So in this case, the default is 3 slices. And so what's the use of this? Well, all these little tools you see here in the preview tab allow you to preview your particles in different ways and kind of troubleshoot them visually so you can get a better idea of what's going on here with the volume shader. So slicing the particles like this can allow you to see the shape a little bit better in a more neutral sense. So you can just kind of focus on the shape for a bit, and then when you're done you can go ahead and place this slices back to none and continue working on your volume cloud. So basically the preview tab, just to remember, is a tab where you can find a lot of different tools and options to control the way that you render out this volume cloud, kind of troubleshoot it and getting it rendering how you want it to render. Okay, so let me turn off preview mode. Let's go over here to frame buffer. The frame buffer tab can be extremely useful because we can use it to render out different data to different frame buffers. We can, for example, render out the ambience here. We can render out the illumination. We can render out the specular, the scattering, which can be very useful for working in post-production, coming in later in compositing. So you can actually render out these different channels in different frame buffers, and then in post-production you can go ahead and adjust and color correct your volume effect any which way that you want. It gives you a lot of power and a lot of control over the rendering of these volume shaders. Then we have a final gathering tab where we can actually activate final gathering, because the volume shaders, one thing to note about volume shaders is that they are totally compatible with mental rate, 110%. These things can work with final gathering, indirect illumination. They can work with regular lights. They can work with area lights as well. Pretty much everything in mental ray these volume clouds can do and work with. So you can come in here in the final gathering tab and work with final gather and your volume shaders happily. Then we have a shadows tab where we can go ahead and adjust some things here for the shadows. For example, we can change the shadow saturation, saturate those shadows a little bit more, or desaturate them and darken them up a bit. Go ahead and put them back at the default. We can also choose the interior self shadows, so we can turn on these two different options here. So we can have all light rays of the lights that are affecting the particle cloud to cast shadows. Or we can set it to one single ray, which is faster, but doesn't look as good as you can see. Okay, so that's pretty much going to do it for the particle volume cloud. Again, for rendering out with speed and quality, the main tabs you want to go to is the marching tab, the lookup table, and the preview tab. Preview tab again just has tools and options for previewing the particle cloud, getting it to render the way that you want. Go ahead and turn those options off when you're ready to do your final render. You can use the marching tab over here to go ahead and set your low settings default or high settings, or if you're feeling like going for a little more in-depth into this volume cloud shader, you can go ahead and uncheck simple mode and control all these different parameters yourself. And of course, the lookup table controls the lookup table for the cells. Remember that the smaller the cell size, the longer the render, but the higher quality it's going to be. The larger the cell size, the lower quality the render, but the quicker the render is going to be. And of course, cell interpolation is going to affect the interpolation, the smoothness between the different cells. Cubic is pretty good. Linear can most of the time work good enough. If not, go with cubic. If you don't mind the render times, you might want to go with full light trace. And then of course, shading, don't forget that we can restrict which lights illuminate our particle clouds, which can also boost our render times and optimize our rendering here by a pretty good amount. Okay, so let's close that. Okay, so I think we talked about the particle volume cloud shader long enough. Again, this may have not been the most exciting video in this tutorial, but it was necessary because it's really important for you to know how to use this particle volume cloud shader and understand the parameters and options, in particular the parameters and options that control the render speed and the render quality, and how to use them to go ahead and control this particle volume cloud, because this node has so many options that if you're not sure what you're doing, you can take a long time to set this up, and probably set it up incorrectly. So there you go. Use this video for reference whenever you want to know more information about the particle volume cloud shader. Okay, so that's going to do it for this one. In the next video, we're going to move ahead and we're going to discover what that easy method that I mentioned earlier in this video was for setting up these volume shader networks, and pretty much practically with the click of a button. Okay? Alright, so that's going to do it for this video. I'll see you in the next one.